Hello guys, this is Yakov Fain with Faraka Systems, and we are continuing our Intro to Java training video lessons. And today we're going to be talking about casting, abstract classes, interfaces, and polymorphism. It's unit 4 out of about 18, I guess. So let's go. Casting. In Java, there is a hierarchy of classes, and on the top of the hierarchy there is a class called object. So every class in Java, your class or Java's class, is a subclass of the class object. For example, if we have an instance of the class njText, actually if you have a class njText, this class is a subclass of text, if you remember from our previous lessons. But besides that, it's also a subclass of object. So technically, the first line over here of creating an instance of New Jersey text is simple. On the left-hand side, you declare a variable of type njText, and on the right-hand side, you are creating an instance of the same data type, njText. On the other hand, what you can do, which is probably a bit unusual, look at the second line. On the left-hand side, you declare a variable of type text, which is an ancestor of New Jersey text, njText. But on the right-hand side, you still create an instance of a subclass. So what we have is we have different types. On the left-hand side, we have a type of a superclass. On the left-hand side, we are instantiating a subclass. And this is an example of something that is called upcasting. Casting in general, it's a conversion of type. Technically, think about it this way. Say you have a collection of objects. You can declare this collection of objects of a generic type of a superclass. But in there, you can put a bunch of objects which are of a different nature, but all of them are sitting in the same hierarchy with the where the data collection belongs to. For example, check this out. We declare an array of type person, and we create a new array that is capable of holding 100 references to different persons, instances of a person. If in our class hierarchy, employee is a subclass of a person and contractor is a subclass of a person, then you are allowed to create instances of employees and contractors and store them in the array, in this case, of a type of a person, which is a common superclass for both employee and contractor. Why you need that, you'll see pretty soon when I'll show you this. I'll show you examples of polymorphism, for example. But for now, just remember that this operation, when the type is casted or converted to a superclass, this process is called upcasting. From subclass to a superclass. I missed one line, but let me comment on that as well. As I said, every class in Java is a subclass of a class object, so this line is also perfectly legal. On the left-hand side, we declare a variable of an ancestor type. On the right-hand side, we instantiate njText, which is a subclass, not direct subclass of an object, but still it's a subclass. Same thing here. In the person array, we put as the first element an instance of employee, second is also an instance of employee, and the third one is an instance of contractor. It'll work just fine. What about the other process? Can we downcast? Convert the type from the superclass to the subclass. And why we may need that? Let's use the same exact array of type person, assuming that person is a subclass of employee and constructor. Say we created this common place for storing instances of employees and contractors. And since we are planning to put both of them there, both types, we decided to declare it of type of superclass. Then we are processing this array. Say, for example, we had a database and we populated this array after reading, say, 20 records from the database. Some of them are consultants or contractors, some of them are employees. And let's assume that contractors have certain specific methods which don't exist in the employee class, and vice versa. Employee class has certain methods that don't exist in the contractor class. If we need to process this every object from this array in a loop, and we want to make sure that we are invoking the methods that do exist in the current object. So one of the ways to do that is to check what exactly is the type of this current object. Remember, the array is of a type superclass, but this current one, the element with an index of 0 or 1 or 2, Java has a special operator called instance of. You can check to see if the object where we are pointing at has a specific type. Like in here. In the if statement we check if the current element of the array workers is instance of employee, we are doing this type check. Then we want to do casting. In this case, it would be downcasting. We are saying, I know that you declared an array of type person, but this particular guy is an employee. I know that for sure. I just checked this out. So please cast it to employee and assign it to a variable of a specific type now. See, I declared a variable current employee of type employee and current contractor of type contractor. After this casting, I have a right to call on the method current employee, on the variable current employee, any method that was declared in the class employee. Because it knows the current employee has a type, is of type employee. And similarly, if, for example, the current element of this array is contractor, has a data type contractor, then I do downcasting. To do this downcasting, you put the type you want to cast it to, the current object to, in parentheses, in front of this object. So this basically means take the I element of the workers and cast it to contractor, and then we assign it to the variable current contractor. After that, you can call any methods that were declared specifically in the contractor. That's how it works. That's casting. Again, upcasting works automatically. You don't need to put any specific conversion on the right-hand side of the equal sign. For downcasting, you need to put the type, in this case it's employee, in the parentheses, in front of the object you're casting. That's an important term or notion of casting in Java. You'll see some examples pretty soon in the code. But now let's talk about other really important term or data type or construct in the language, which is called interfaces. Interfaces mainly are about behavior. Classes typically have behavior and they have properties or attributes. Interfaces is a declaration without implementation. What does it mean? Say, for example, we believe that there is a useful behavior that more than one class can exhibit or share, so to speak. And we can create a construct called interface. like in this case, public interface payable. I gave it a name payable. I decided this way. And in there, I declare methods that must be implemented in this interface. When I say must be, I mean at this point it's not implemented. At this point, I just put a method signature saying that there should be a method increase pay, which should take one argument of int type, percent of increase, and it should return a data type Boolean. That's what it is. You can say, why bother? Why would I even declare this method over here if I am not planning, or actually I'm not even allowed to implement it here? The idea is that this mechanism of interfaces allows developers separate reusable, say, behavior. Think about it this way. We believe that we will have class employee and class contractor. They will have some specific methods, but we also know that both of them should have such behavior as payable. Each of them can be paid. And then I am a senior team lead in Java, and I have John and Mary working for me. They are junior programmers or even mid-level programmers. So I'll say, John, you will be working on the class employee. And you need to provide a way to increase the pay of the employee. Mary, you're going to be working on the class contractor. And you also need to provide a way to increase the pay of the contractor. And to make sure that you will not try to come up with some fancy and different names for increasing the pay. For example, John will say, okay, I will call my method increase salary. And Mary will say, all right, he's a contractor or she's a contractor. Let me call this method increase hourly rate. In that, it's possible, that's okay, but if I want to have standardized or generic interface, I want to make sure that both employee and contractor have the same method, at least a method with the same name. When it comes to increase the salary, everybody will call a method increase pay, regardless if it's an employee or if it's a contractor. I create unified interface to all my classes. And you'll see pretty soon why it may lead to a more short and elegant code. So technically, I'm saying, John, you're going to be working on the class employee. Make sure that it implements payable. Mary, you're going to be working on the class contractor. Make sure it implements payable. Remember, in one of the previous lessons, I think it was lesson number 2, when I was talking about inheritance, I told you that in Java, you are not allowed to create a class that is inherited from more than one class. It's not like a person, each of us inherited something from father and mother, but in Java you can only inherit from one class. So there is no multiple inheritance in Java. But you can inherit from one class, but you can also say that your class implements more than one interface. It's not multiple inheritance, but it's kind of give you some flexibility to specify that my class will exhibit certain behavior. In this case, I said that the class employee will implement payable, and it will implement promotionable interface. I don't even put the definition of this promotionable. Maybe there are some methods that mean promotion in our company. And when I say in the class declaration implements, I take an obligation that let's take the second example, contractor. If I said that contractor will implement payable, it means that I guarantee that the class contractor will have implemented all methods that were declared in the interface payable. In our case, we declared only one method, Boolean increase pay. So which means that class constructor will definitely have an implementation of the method increase pay. When I say definitely, I mean you will not be able to even compile your program unless you implemented this increase pay in the class constructor. Same thing about employee. If an employee said that I'm going to implement payable and promotionable, it means that employee promises, not promises, guarantees that I will have all methods implemented that were declared in the interface payable, as well as all methods that were declared in the interface promotional. Sometimes in the books you will read that when you write that a class implements certain interface, it means that they are entering some kind of a contract. The class is obligated to implement everything that was declared in the interface. The next question you can ask, is this the only thing that you can put in Java interface? I mean, only method signature. The answer is no. You can also put in there final variables. So if you will write inside the interface any variable, it obviously you can write that it's final, but it automatically becomes final. Not only final, but also static. It'll be shared by all instances, because interface is shared by many instances. So inside the, on the next slide, I think you will see it, but just for now, just remember that you can put in there method declarations and final static variables. As of Java 8, which today is middle of March, no, sorry, today is middle of February of 2014, and on March 18th, Oracle promises to release officially Java 8. Java 8 introduces something else in the interfaces, so-called default method or defender method. I don't want to confuse you for now. Let's pretend that we don't know about Java 8. Later on, eventually, I'm planning to record a presentation about new features of Java 8, and over there, I will explain what it is. But for now, just remember that up till Java 7, you can declare in the interface a method or a final variable. And now we'll do the walkthrough number 1. In the walkthrough number 1, we'll touch a little bit upon the interfaces, and we'll see some casting examples. Over here, I'm asking you to download the project lesson 6 from textbook and import it into Eclipse. You did it already in the past, so I assume that you know how to do that. I already did this in my Eclipse, but what we will do in this lesson 6 project, we will open up and see what's in the class person, what's in the class employee, and what in the program test pay increase. Test pay increase. Let's see what's in there. This is lesson 6 in Eclipse, which I already imported. And we have a bunch of classes. Let's go back. What do I want you to do? I want you to open up the class person and the class employee, and then check the pay increase. This is the class person. What do we have in the class person? In the class person, we have declaration of a variable name. We have a constructor in line number 6 to 8, and we have a method getName. Fine. What do we have in the class of the employee? Oh, class employee is interesting. It extends person, right? It's a subclass of a person, and besides that, it implements payable over here. So by looking at this line number 3, I can say that I know who is the superclass of this one. Superclass is person, and also what I know that this class implements payable. What's in payable? You can right-click and do open declaration or F3. And let's see what's in there. I declare this interface, public interface payable, and in there I declared one final static variable, increase cap. It's like a limit of increase. Say in our enterprise, you can increase the salary of an employee without any restriction, but if it's a contractor, you cannot increase the pay rate more than 20%. So this is what I want. So it's a final static variables. Again, let me remind you, if I will forget, or if I will not put, let's say, I will forget writing final static over here. It looks like it's not final and it's not static, but in interfaces, all variables that you declare are implicitly final and static. And we declare in there a method signature of the increase pay. So if any class will say, or if you will write that the class implements payable, then it means that you must implement increase pay. In this case, what do? I just print increasing salary by percent and then get name. Get name is a method from the superclass, correct? Now let me say I made a mistake. I misspelled this increase pay and say immediately I'm getting an error. Look at this little red cross. You can probably guess already, right? The type employee must implement the inherited abstract method payable.increasePay. It means you said that you will implement payable interface, so where is the method increase pay? So there's no way that you can get away without implementing all the methods which were declared in the interface. All right, so this is employee. What do we have in contractor? Similar story. Contractor extends person, implements payable. In this version of increase pay, it's a bit different. In this version, we are testing if the argument, if the parameter percent is less than payable.increase cap. Then we will output the message, print the message on the console, increasing hourly rate by a certain percent. Otherwise, we write can't increase hourly rate by more than, and again, the cap. We attach the cap. Please note, since increase cap is static, you don't need to, there's no way that you can create an instance of an interface, right, in general. But the notation, look at the notation. Name of the interface, dot, and the static variable that exists there. Again, in employee, we don't check the cap, increase cap. In contractor, we do. And test pay increase. Test pay increase. We create an array of type person and we put in there 3 instances. Employee John, contractor Mary, and employee Steve. And then in a loop, what I do here, line 19, right? I'm using so-called for each loop. I wrote here for a variable P of type person, and for each element in the array workers do something. And the body of the loop is from its line number 20 till 29. I check the instance. If the instance is of employee, I cast the variable P that is originally declared as a person, type person, to employee, and I do this increase pay. And if it's instance of contractor, line number 25, I cast it to type of contractor, increase pay. I want to tell you immediately that this is not the best way of writing this code. It's valid, it's legal, the syntax is correct, but I keep it on purpose. I am using this instance of operator, which you should try to avoid. If there is a way to write your program without testing type, and how to do that you'll see in 10-15 minutes, it's better not to use instance. Instance of is considered an expensive operator. Expensive in the sense that it takes system resources. It's slow. So it may, if you will have a collection of 100,000 of elements, and for each of them you will do this instance of check, it adds up and the processing will slow down. So try to avoid using instance of, but you have to know that such constructor, such a syntax element exists in Java. So right-click run as Java application. All right, so it works, right? It works as expected. In a loop, we were iterating through the array of workers, and we are calling method increase pay on different elements, on employees and on contractors. Let me create a specific situation, like to illustrate interfaces a little bit more, or casting. Say public. Let me declare a method in the employee. Public void. What do we? Let's come up with something that employee can have. Employee can have for one pension plan, right? Add pension like this, right? Pension plan. System out println. Adding, and yeah, I'll just output any text. Adding pension plan for get name we can, right? Get name. So now employee and contractor are even more different because employee has a method add pension plan. Now let me go back to the test pay increase over here, right? And let me create this situation. I will try to call. Can I call the method add pension plan to the contractor? Control space. Nope. It doesn't even see it, right? There is no such a thing. Increase pay, it's there, but there is no method that is called add pension plan. So some kind of a justification of casting in this case could be if we have a need to call specific method that exists on the employee. So that's why we did the casting in the first place on the line number 21. Control space. See, add pension plan is there. I am allowed to call add pension plan on the employee. I'm not allowed to do it on the contractor. So this is one of the reasons which you may need to do casting if you want to call specific methods that exist on this type. In this case, on type employee. Let me run it again. Yeah, see, adding pension plan for Steve. For John, because both of them are employee, but not for Mary. Okay. Alrighty. We will keep using these interfaces and casting more and more, so you'll get used to it eventually, hopefully. Now I want you to learn something new. There's a concept called abstract classes. Abstract classes. See, this is me. I'm a team lead. I'm thinking I need to design some program and I want it to have person. I want it to process people. What kind of workers do we have at work? We have employees and contractors. Do they have anything in common at all? Of course they do. Both of them are people. Both types. And every person has a name, right? Employee has a name, contractor has a name. Maybe there we want to add a method called change address. Such a function as, or operation as change address is the same for employees and for contractor, right? So when I'm sitting like this, thinking what classes to create in my project, I can decide. Let me create a class person and put in there all functionalities that is common for both employees and contractors. Then I'll create a couple of subclasses, employee and contractor, and in there I will put something more specific. So far, so good. Again, I have John and Mary, programmers working for me. I'm a team leader, big boss, right? So, again, I want to make sure that there will be a method increase pay. And I want to make sure that both of them are naming it exactly the way I want it and the same way, increase pay. We just went through that, how to do that in case of interfaces. But now, I want to implement certain functionality in the superclass person, but still I want to force them, my programmers. I want to make sure that even though we are not using interfaces in this example that we are talking about now, I want to make sure that each of them will call the method increase pay the way I want it, and the method signature will be the same. How to do something like that? You can declare the superclass person as an abstract class. Abstract means unfinished. A more formal definition is the class is abstract if it has a keyword abstract in front of it in the definition. But the point is, if you have an abstract class, typically you will have in there an abstract method. And if I will put the keyword abstract in front of the method increase pay in the class person, again, I will force employee and contractor to implement this method, increase pay. If they will not implement it, they will not be able to create instances of employee and contractor. So all these subclasses remain abstract until they implement all unfinished, so to speak, methods from the superclass. Why we do this? Maybe tomorrow we need to create a new type, Gastarbeiter, right? People who came on visitor's visa but decided to work, Gastarbeiter. So we also have increased pay over there, but we do it like kind of under the table, we pay them cash. Still, we need to implement the method increase pay, but we will do it a bit differently. So let's see how we can do something like this. Again, formal definition. A class is called abstract if it was declared with an abstract keyword. Just like this. See this first keyword, abstract. This means that you cannot instantiate this class until one of the subclasses will implement abstract method. In this case, we have not abstract, but concrete method, change address. But we also have something else, some other concrete implemented finished method that are generic for every person. But what else I did over here? I said I want to have public abstract boolean increase pay. I have an abstract method and it must be implemented in one of the subclasses. Yes, abstract means unfinished. And to illustrate this concept, I will show you how we can do something like this. Here's an assignment. A company has employees and contractors. Design the classes without using interface. I'm just showing you a different technique to represent people who work for this company. And the classes should have the following method. Change address, promote, give day off, increase pay. And promotion or method promote. Promotion means give 1 day off and increase the amount of the paycheck. That's how I decided. So how do we think about it? We are not going to be using interfaces, then we're going to be using abstract classes. In that abstract classes, there is something that is common for both, for both types, employees and contractors. Yes, change address is the same, so there is no reason to copy implementation of change address in the class employee as well as the class contractor. Now, promote. What is promote? As we define, promotion means give 1 day off and increase amount of the paycheck. Okay, I understand. Then what I'm going to do, I'm going to create a method promote, and internally I'm going to be calling the method give day off from promote and increase pay. Fine. I understand that. Now, increase pay. I understand that employees and contractors are different species, and increased pay should be implemented different. So then I will declare the increased pay is abstract. Let them, when they will subclass my person, let employee will implement an abstract method one way, and for contractors the other way. This is how I think. And this is how it looks. It's in listing, in the textbook it's listing 7.1, if you want to look at it over there. So I declared abstract public class person, declare in there anything you want, like you would do in a regular class. I decided to declare a name, increase scape, this is a constructor, getter, get name, change address. All these are concrete methods. Now, give day off. Please pay attention. I declared this private. What does it mean, private? In this case, no, in any case, basically, it means that this method is internal for the class person. Nobody from outside will use it, will invoke it. So give day off will be used only from within the method promote. And as I said, the method promote means give day off, and we need to call the method increase pay over here. You will see the code now where I actually do this. Over here, I just put it as a comment. Now, what about increase pay? Again, as I said, we don't know, we don't want to implement it here in the abstract class. We want to let the subclasses implement it the way they want it. That's an example of an abstract class. And in this case, class employee extends person, and they will implement the increase pay one way over here. Check this out. Now the method signature does not include the word abstract because it's not abstract anymore, right? And over here we have the increase pay implementation for the class constructor. Again, it's not abstract anymore, it's concrete now. Different implementation, but after the implementations are done, this gives us a right to create instances of class employee or a class contractor. And by the way, check this out. We have, both of these classes have a constructor. This guy has a constructor employee, of course, has to have the same name as the name of the class. And what we do over here, we're just calling, we are passing to the superclass the name of the name that was given to this class while instantiating. So super and parenthesis means invoke a constructor of a superclass. All right. That was implementation with abstract classes. Now, let me go back again. Do I have to, or can I always use implementation with abstract classes? Again, let me remind you, abstract class means something is implemented in the class person, in the superclass, and something remain abstract. Is there a situation or a use case when I cannot do this, when I cannot use the mechanism of abstract classes? Yes, there is. In some cases, you write a class and you must inherit it from a certain class. For example, Java has so-called applets. Java has servlets. Different technology, different ways of writing programs. And if you want to write an applet in Java, your class, whatever the name of the class is, must inherit the class, say, JApplet or applet. If you want to create a servlet, special server-side class used in the web applications, you have to inherit servlet or HTTP servlet or a generic servlet. So you have no way to create another abstract class and inherit it from both, from servlet and your abstract class. So in some cases, you cannot even afford, so to speak, to do that. If you can't, what remains at hand? Interfaces. Again, if you are forced to use inheritance from another class, or simply you don't need to have a common superclass, you can just use a mechanism of interfaces. Now let's take a look at different implementation, different solutions, so to speak, of our task. No more common ancestor, no more class person. I will declare an interface payable, and I will declare a class employee implements payable, no inheritance. And I declare another class contractor implements payable. By the way, this diagram that you see, it's so-called UML diagram, United Modeling Language, UML. In the section at the end, additional read, I recommend you to read a certain book, small book, UML Distilled. Programmers are using in program documentation all these diagrams, and I would recommend you to get familiar with it. What does it mean in UML language? Now, let me give you one more explanation, so to speak, of a term, polymorphism, and then we'll go to the code, and then we'll try to run something and review the code so it will become a bit more clear. A polymorphism is when a different object, when object can show different behavior based on something. And let's see what it means over here in our programming world. Let's just review this code for now. I have an array person, 3 element, type person, and I put in there 3 instances: employee John, contractor Mary, and employee Steve, like we did before today. But now let's look at this code, at this loop. If you remember, in the previous version, the code was a bit more convoluted. See this? Lines from 19 to 31. Look at all this code. We were iterating through this array, we were checking the instance of the current object, and then we did something. But over here, everything is gone. In this, for each loop, we declared a variable p of type person, and we say for each element in the class, in the array workers, please call this method, promote. Call this method, promote. This is an example of polymorphism. This is an example of polymorphism. To be honest with you, this slide should go a bit up. It should go right after the abstract classes in my example. But still, let me explain you what it is. Java is smart enough to understand what is the current object that is sitting in the collection, in this case inside of the array. When we call p.promote, Java will check the type and properly will invoke promote, the code of the method promote, either as it was written for employees or as contractors. So when you look at this line, it looks like we do the same thing for person, but we don't. And this is basically a nature of polymorphism here. So even though it looks like we call the method promote on every object of this array, but technically we will be calling different methods promote, depending on what is the data type is, employee or contractor. And now we'll see more code, basically. Let's do walkthrough number 2. Walkthrough number 2 says that you need to download lesson 7, which I already did, and import it in Eclipse, which I already did, and run the program test pay increase. Test pay increase, so let's see. Lesson 7. test pay increase 2. That's the code that you just saw on the slide. But let's look at our guys, employee and contractor, how they are defined. First of all, person. Abstract class. It's an illustration of abstract classes, by the way. Employee extends person and implements increased pay. Contractor extends person and implement differently increased pay. But again, person, it was an abstract class and it had one abstract method somewhere down there. Yes, abstract increase pay. The method promote was calling internally. It was calling give day off and increase pay. You can say, how come you're calling increase pay, but it's not even implemented yet? Yes, it's not implemented, but this code of a class person will never be instantiated until one of its subclasses implements the abstract increase pay. So we are safe over here. Test increase 2. We'll finish our illustration of abstract classes. Right, promoting work and giving a day off and so on. So check this out. Even though this line, test pay increase 2, line number 13, looks as if we are calling the same method promote, we are actually calling different methods. One of them just blindly increases salary by whatever percentage you specify, but the other actually checks to make sure that contractors will not get more than certain cap. Right? So the code becomes more elegant because of all these features that are supported by Java. Back to the slide, and now this was an illustration of the polymorphic behavior with abstract classes. Can you do the same thing with interfaces? Sure, you can. Let's look at the other example. The other example assumes that both employee and contractor implements payable. If you open up the textbook in these listings 6.2 and 6.3, you will see over there that these two are just the classes, no common superclass. They are not inherited from the person, but both of them implement payable. Let's look at this code. This code looks kind of weird, at least for the first time. Look at the data type. We are declaring that an array of workers of type payable. Payable is an interface. So what does it mean? It's not even a class. We are saying, I don't know what these objects that are stored in workers will have and will know how to do, but I definitely know that each of these objects will implement methods declared in payable. This is what it means. If you remember, we declared only one method in the interface payable, which means that every object, on every element of this array that was declared as payable, we will be able to invoke only one method, increase pay, because we said that I care only about methods that are defined in payable. So again, this is also kind of weird. You're not creating an instance of an interface. You're just creating an array that is big enough to store 3 references for 3 objects that implement payable. You may want to rewind a little bit and think again and listen to me to what I said again, but eventually it should fit, it should fall into place, the whole puzzle. And the rest is similar. You create a new instance of employee, new instance of contractor, new employee again. Important, you're allowed to do this only because each of these employee and contractor implement payable. And then, very similar, you write a loop for each type of loop, right? But again, it's pretty interesting, right? The data type of the variable p is of type payable. Again, you're saying, I need a pointer. I don't know what kind of object it's going to be, but I definitely know that it'll implement payable. So payable p workers, and you do p increase pay. See, Also, another example of a polymorphism, it looks like we are calling the same method increase pay, but technically we're going to be calling different methods increase pay. Alright, I think we reached the end of the lesson, and this is the homework. You need to study materials from lesson 7, and those of you who are studying with me in the group, come up with something with your own program that can illustrate use of interfaces and abstract methods, like cats and dogs, men and women, something that every animal has in common. Right? You can create an abstract class animal and a couple of subclasses cat and dog. Cat cannot bark, but the dog can. Otherwise, each of them needs to eat and sleep and so on. Something like this. Think about it. And some additional reading for you. Alright guys, thank you very much. This completes and concludes the lesson number 4, Unit 4. My name is Yakov Fain. I work at Farata Systems. Till next time.